So the next step is, or kind of happens at the same time, we have what's called the tower, Targon Tower. So that lives like down here. We'll say it's this. All this does is give a source of truth for the tau price, the max bid allowed for the miners, and the live auctions that are happening. Yeah, and again, this is just like the beginnings. There's so many things that we're working on and implementing, and this is just the flow for the subnet in the view of Bittensor. The way we actually run inference on these things and process user requests is a totally different architecture. It's a totally different flow.
But fundamentally, on Subnet 4, we need compute. That's why we started Subnet 4. I think compute is going to be a very large commodity tomorrow. It's pretty big today. I think it'll be larger tomorrow. Probably not a crazy thing to say. People are going to use more compute tomorrow than today. Ultimately, I think everything on Bittensor is a commodity. That was the premise initially, and I think it holds true today. A digital commodities marketplace. How do you produce this in the most efficient manner possible while maintaining quality, price, whatever it is that you're optimizing? That's the beautiful thing about Bittensor, is we don't need to do the Uber way, which is much harder. I've actually seen people who are trying to do the same thing. The beautiful thing about this idea is it's so simple that even we can talk about it, right? It's not like this crazy abstract thing. It's simple.
Welcome to the Ventura Labs Podcast. Today, we're joined by some of the leadership of Manifold Labs. Josh unpacks Targon's internal system, validators, CVM attestations, and the 72-minute H200 auction that sets real-time GPU prices. James gives an overview, explaining order book bids, collateral tiers, and the importance of a marketplace for decentralized compute. Now, back to James and Josh with the 53rd Ventura Labs Podcast.
Josh,
What's that go?
CTO from Manifold. We're keeping that in, just because I don't know what that was. But we're here with Josh, the CTO of Manifold. How you doing, man?
I'm doing all right. How are you?
All right, I'm good. I'm here to figure out how your incentive mechanism works,
Sure.
how this new bidding system works. What is Targon?
All right, those are big questions. Let's start at what is Targon. So, get a little whiteboard space back. We're just going to start from the top and kind of run through how the entire thing works. So, like any Bittensor subnet, you have your validators, right? Your validators are arguably your most important part of the actual subnet in terms of like truth bearers. So, these are our validators. Now, the validators need to communicate with the miners. So, for our system, you have a centralized set of validators, and then each miner has a set of what we call CVMs. Now, in front of the CVM, they run the miner proxy. So we'll say that's this. Proxy. Let's say we have two miners in the system. So these proxies, their only job is to report to the validators their IP addresses and their bids. We'll get into that later. So let's say this miner has x.x.x.x, and let's say he's bidding 200, and then you have another one, 200, and say 150, right? And then this guy also has his own list of IP addresses with bids. So at the start of every interval, this whole process basically runs every interval and starts from clean slate at the start of the interval. So you can essentially assume that from one interval to the next, no data is carried over.
Every 72 minutes.
Every 72 minutes, every 360 blocks. There's virtually no data carried over. Every interval, it starts by the validators talking to the chain. I'll just say this is the chain. Validators will grab the list of neurons from the chain, so they know where these miner proxies are. Then they'll hit the miner proxies and fetch their list of IP addresses. So now these each contain the list of all these miner IP addresses and their bids for all of their CVMs. So then behind these miner proxies, loosely behind, not literally behind, you have the CVMs.
And is a miner proxy a singular miner?
Yep.
Okay.
Every miner has one miner proxy.
So then the multiple bids is going to be...
for each of their CVMs.
Okay.
So the idea is you have one miner proxy, which is essentially the only thing that actually interacts with your with the chain, with the Bittensor keys, and with the validator in terms of like chain stuff. And then these are what you're actually getting incentive for. So if you just ran a miner proxy and didn't report any IPs, you wouldn't get anything because these are what you're getting paid for. But in order for the validators to know about these, it has to talk to the miner proxy to get this list. Does that make sense?
And this list is going to be, we have this many H200s, this many H100s.
Effectively, it's not literally this many. It just is literally an array of IP addresses and bids. That's it. It's just, I have an IP address and a bid, IP address bid, IP address bid. Doesn't say what they are, doesn't say anything about them. It just says, here's an IP address and here's a bid. That's it.
Okay.
So each of these would line up to one of these. Right? Sorry.
A 1-to-1.
1-to-1, yeah. So in this case, like this miner only has 3. Right? So this is their 3 IPs they're reporting. These are the 3 CVMs that these IP addresses correlate to.
And an IP address can correlate to a cluster, like a 8 by
Yep.
H100.
Yep.
Okay.
Each IP address is what we call a node. So a node is an 8x H100 or H200, or could potentially be a 1x H200. We don't have any 1x H200s running on the subnet. It generally always makes more sense to just run an 8 box. You get paid out. This is your per GPU rate in cents.
Okay.
So this is, I want $2 per hour for each GPU in this cluster. Because you're not going to have a cluster that like mix and matches H100 versus H200. So it makes sense to bid all of the GPUs in the cluster the same. So now the validators have this list of IP addresses and the bids from these miners. So the next step is, or kind of happens at the same time, we have what's called the tower, Targon Tower. So that lives like down here. We'll say it's this. All this does is give a source of truth for the tau price, the max bid allowed for the miners, and the live auctions that are happening. So all the validators will hit this as well. So I'll write this down here. We'll say max bid, auctions.
So this is similar to Oracle.
Yeah, max bid, auctions, and tau price. So that way, all the validators agree on a tau price. The other thing the validators will get from the chain is the current amount of emissions flowing into the subnet at that interval. Or, sorry, at that specific block multiplied by 360 for the entire interval. So essentially it's like, if Targon has, let's say, 5% emission at that block, it'll say Targon is getting 5% emission at this block. It'll take the tau price, multiply that by 360, a couple other numbers are in there, and it's basically just a calculation of how much US dollars is flowing into our subnet 4 at any interval, at the start of the interval. And that's what we call our emission pool. So that's how we know how much we can actually pay out these miners.
And that number's just based off of the alpha out.
It's based on the emission, which I'd have to look at what that number corresponds to in terms of alpha in, alpha out, tau in, tau out. But at the end of the day, the emission pool is the amount of dollars flowing into the pool, and basically what we have to pay miners out. So you can think of it as like there's the 41, 41, 18 cut. It is the US dollars of the 41 cut. Make sense?
Yeah.
Is that alpha out? Okay, yeah. So the alpha out.
Technically, to get to US dollars, you'd have to convert it to the pool. So there's a conversion rate.
Yes, and all that is done on each of the validators.
Oh, okay. So you factor in the conversion rate too, the slippage?
No, not the slippage. It's just the emission at that.
Okay.
It's the emission coming in at that block multiplied for the full 360. Because we can't like oracle what the price is going to be for the future.
Yeah.
We could do it at the end, but it's good enough doing it from the start of the interval and then just predicting out to what the future is going to be at that rate. There's enough alpha in our subnet. The price isn't insanely volatile. So
second largest pool currently.
So yeah. So where are we at now? We have the validators have this list of IP addresses. They have the emission pool. They have the auctions, and they have the max bid. So the first thing they'll do is go over all these IP addresses that all the miners report and normalize these bids to be either a minimum of 1 cent per GPU per hour or the max of the max bid. So now it does that. The next thing it'll do, so again, we're basically at block like the second block of the interval. We're like right at the beginning. We really haven't done much here. For the rest of the interval, the validators will go and ping every single one of these CVMs 5% of the blocks of the 360. Now, there's an important key here. These validators will, at the start of the interval, they'll actually, all of them will always ping all of the CVMs for their, what we call the attestation report. So this is it's basically like a JSON blob, JWT token, with a bunch of information of the actual GPUs running and a whole bunch of other metadata about the system itself, along with some information that we bake into it that when it's processed, it requires a nonce. So the validators will generate a nonce, send it to the CVM. It'll generate the report using that nonce, send it back to the validator, and then they can verify that the attestation was generated with that nonce. And in fact, the validators actually check with NVIDIA. So all of these are talking to NVIDIA for each attestation result, asking, is this valid or not? So we're actually getting guarantees from NVIDIA themselves that whatever reports we're getting back from these CVMs are valid.
So in a hypothetical world, you guys become way larger than NVIDIA. They could be a vulnerability.
Sure. I get, define we become larger than NVIDIA. So the way these are generated are the H200s themselves have cryptographic keys baked into the hardware itself that you can't get out. Very similar to how like TDX works. And so this report that's collected, it's uses what's called evidence. It'll basically collect this GPU evidence that's includes part of this key, kind of. It's a weird process. But the point is there's a cryptographic key that only NVIDIA has, and they can verify whether this attestation report was generated with this hardware because they know the key that was baked into the hardware. Does that make sense?
Yeah.
Right.
So if NVIDIA wanted to mine, they could, and not provide any GPU.
I suppose that would be absurd. That would be absurd corporate espionage.
Well, they're only a $4 trillion company currently.
Sure. There's other checks we can do to make sure that the CVM is actually what we expect it to be. So there's a whole bunch of things that happen under the hood when these things start up, and we can kind of tell, is this reasonable or not? And we would know right away if someone spun up a CVM that was trying to be a malicious actor. So every interval, again, so going back a little bit, the start of the interval, the validators will ping all these CVMs and get their attestation reports. Now, something important is these CVMs can only process one attestation request at a time, and the request generally takes about 5 minutes-ish.
Okay.
So that means if this validator sends a request to all the CVMs, and all the CVMs get this validator's request first, any other validator trying to hit these CVMs will get a busy code. And these will basically say, hey, I'm processing someone else's request. You can't hit me right now. So what happens is, after that first round, they literally will generate a random number every block and just see, with a 5% chance, should I ping all the CVMs? And if so, then it pings them. And then this way, all the validators randomly send out attestations. So that way, we don't accidentally have validators stepping on each other's toes. Does this make sense?
Yeah. And they randomly send it to all at the same time?
Yes.
Okay.
Yep. Now, they send it to all that have not already passed for that interval.
Okay.
So if this guy responds to this validator on the first try, the second try from this validator won't try and ping this guy again because he's already passed for the interval. So you only have to pass once. Now, you'd think there'd be an attack vector here with like, oh, you just spin it up, pass, and then shut it down. These things take a long time to turn on, let alone turn off. It doesn't make sense to turn them on, turn them off, turn them on, turn them off. Like, you can't do anything useful by doing that. So
what is the time for turning on, turning off there? Because if they pass one, couldn't they just take it offline since they're good for the next however many minutes?
They could. So right now, we haven't seen this be a problem. We have built-in health checks that run all the time, regardless of if you pass or not. And if we see that like health checks start going down, we see someone turning on and off a node, we would see that in our infrastructure very fast. And we could just implement, hey, you just have to keep your node online. But again, it doesn't make it's impossible to like turn it off and on fast enough to like make that make any sort of sense.
Yeah.
So generally, we're not worried about that. So that's the whole attestation flow. Now on to the auction system. This is where things get fun. So at the end of this whole interval, all the validators have pinged all the CVMs. They've gotten all the attestation reports. All the validators know who's passing everything, yada, yada. So now this big list of passing CVMs along with their bids. So we have this big list, right? Now what happens is we will take all these IPs and bids and sort them into buckets based on the bid. So you'd have like a bucket for 200. My marker's dying. And then it would be this IP address, this IP address, this IP address, along with the bid, which I guess is already there, and then the UID. So let's just say like UID like 0, right? Or let's say, for example, like 1, right? And then you have like 300. That would be X. And then like let's say 300. And this is UID also 0. So what we'll do is we'll start from the lowest bucket first. We'll sum how many GPUs there are in that bucket multiplied by the bid. And if there's enough money coming into the pool to pay all these people out their exact bid, we'll pay them out their exact bid, scaled up to 72 minutes. Ah, thank you.
New marker here.
New marker.
And this bucket, this is, say, H100. This is a specific type of GPU is how you do the buckets?
Yes, so we'll go back a step. So this is the H200 auction.
Okay.
So remember this, part of what's reported from Tower is what available auctions we have. And so this is the H200 auction. It'll look at all the bids for H200s, and then you'd have this whole thing repeated for any other auction we run. Now, right now we only have H200s. We're working on a bunch of other GPUs right now. But actively, this is the only one that matters. But again, when you think about the different auctions, it works the exact same way. Attached to these auctions is the percentage of the emission pool that goes to this auction. So say we had like 4090s, for example, then I would say H200s get 80% of the emission.
That's just going to be an arbitrary number you guys decide.
Yep.
Okay.
Yeah, it's how much we want to pay out for the different type of GPUs. And that way, if we need more 4090s, we just incentivize more towards 4090s. If we need more H200s, we incentivize more towards H200s.
Yeah.
So for this example, this is H100 and it's running at 100%. So we'll look, we'd say, okay, we have enough money in the pool to pay out all of these bids at 200 perfectly. We pay them all out. Then we look at the next ring and we'll sub it up, see if we have enough to pay them out. If you do, pay them out, rinse, repeat. Until you get to a point where you take a ring, you sum up all the bids, and you say, okay, I don't actually have enough money to pay out this ring. I've paid out everybody else before me, but I don't have enough to pay out the next ring. It'll stop and essentially find out, okay, with the remaining money I have, how much should I pay each GPU? So say I have $100, right? And we have, I'm going to make this math easy. Say we have 8 people bidding at $10 an hour, and then 2 people bidding at $15 an hour. The 8 bidding at $10 an hour would get paid out fully because that's $80, and then there's $20 left. So those get paid out fully. Then you have 2 people bidding 15. Now there's some to 30, but there's only 20 left in the pool. So what will happen is it'll take the $20, divide it by 2, since there's 2 other people remaining, and just pay them out both $10.
Okay, so I got that. That's pretty straightforward.
Yeah. Now the interesting part of this is, let's change the numbers a bit. Say there's 9 people bidding $10 and like 5 people bidding $15. Then there would be, you pay out the 9 people, so then you have $10 left. And now there's 5 people bidding $15, but there's only $10 left to pay out everybody else. What happens is those 5 people bidding $15 now only get paid out $2 each. Does that make sense?
Why wouldn't they just take the machine offline? And they're like, I don't want that.
So that's the interesting part. They can either take their machine offline and say, I can't bid any lower. I can't run on anything less than $15 an hour. Then we don't want that machine, because as long as it's online and it's working, we can run workloads on it, because our main business is inference. So as long as the node can come online and download a model, and we do these checks inside the CVM to make sure that can be done, as long as it can run the model and get network requests to it, these things it doesn't really matter. Like, it can run whatever inference we throw at it. It's H200 and H200. Now, there's a lot of stuff on top of that, like not all of them are equal in networking, not all of them are equal in storage, yada yada. But as long as you have enough storage to download a model, you have enough bandwidth to download the model, they're the same thing essentially. Like, it's still an H200 at the end of the day. Now, if we were doing training inside of these, if we were doing like fine tuning, that sort of stuff, now that's a different question. Now we need to take into account, okay, do you have like InfiniBand between the nodes? Do you have like all these sorts of things? But because we're not using these nodes right now for those things, we can treat them all the same. And this lets us arbitrarily drive the price down and basically say, okay, look, if you need $3 an hour to run a GPU on our subnet, then either the price is high enough coming into the subnet that we can afford to pay you $3 an hour, or it's not and we can't use your GPU. And essentially the market will perfectly figure out what the average price should be. Because if there's too many GPUs in the pool, then the average price goes down. If the average price goes down, the people that can't afford that go off, and now there's more money in the pool. And it will kind of like very quickly find its efficient price. Does this make sense?
Yeah, we'll find the equilibrium.
It'll find the equilibrium for like what the price should be.
How do you create classes of compute? Like you're saying InfiniBand versus no InfiniBand. How do you do that?
Sure. So that's one of the problems we're working on, is how do we create another bucket of auction. So like right now we treat this H200 bucket that we're sending 100% to as interruptible compute, which is why it's so cheap. This is, look, if the node just randomly goes online, that doesn't hurt us because it's just running inference. So say we're running like DeepSeek R1 and we're running like 2 instances here and 2 instances here. If one of these nodes just goes offline, it doesn't kill our inference. We just stop sending inference requests to that node. So we treat them as interruptible. Now, if we wanted an H200 auction for like training or stuff like that, then we would have to build out the rules for, okay, in order to be in this auction, you have to have InfiniBand, you have to have this, you have to have that. And then those are checks we would add inside the CVM as part of the attestation result. And then that way it's like, okay, if you want to be in like, say, the InfiniBand H200 auction, then part of what gets sent back from the attestation would verify that you actually have that.
Okay, so
and then,
like check the specs.
Exactly.
And then for non-interruptible compute, I'm assuming you guys would just add a collateral layer.
Yes.
To that.
Yes. Yep. Exactly. So we would have like a smart contract. You put in your collateral, and the validators would just look up, make sure you have that collateral posted. Yada yada.
Yeah. I mean,
so
pretty straightforward for a compute marketplace.
Yeah. And again, this is just like the beginnings. There's so many things that we're working on and implementing, and this is just the flow for the subnet in the view of Bittensor.
Yeah.
The way we actually run inference on these things and process user requests is a totally different architecture.
Yeah.
It's a totally different flow.
Well, that can be arbitrary between users if you guys were doing it versus somebody else.
What do you mean by that? Explain.
Like, this is how you get the compute.
Yes.
How you guys run inference is completely to your discretion.
Yes.
And someone else could use the same compute completely differently.
So right now, we're the only ones that have control of this compute. No one else can control this compute. So because of what runs inside these CVMs is very proprietary to us, someone else can't run their own CVM. Because that's an exploit layer. Like, think about it. If I gave everybody if we let anybody make their own CVM, then you could just rent an H200, put your own code in there, and now you're just getting paid to have an H200.
So what does the roadmap look like for allowing other people to use the compute?
It would most likely be they would use the compute through us. Okay. So we would basically bootstrap the machine. We would take care of all the management side of things, and then they would run whatever they want to run through us on these. So the thing that we're tackling next in that aspect is being able to just run arbitrary Docker images from users on these. Now, it's still a little bit down the road. There's a lot of other things that we want to work on first, but that would be the idea, is you give us a Docker image, and then we just figure out where on the fleet to put that Docker image and then run it. What
about for the people that don't even want you guys to see what they're running? Is that possible?
For us to literally not see what they're running with like 100% certainty, I would say at this time, probably not. That's something, of course, we can explore.
Yeah.
At the end of the day, there's a lot of maintenance and work that goes into what's running inside these. So one of the cool parts about how this works is once the VM's running, like we basically have total control over what's running on the inside of the VM. So say that we want to update the code running in these things. Because we have complete control, we can actually just go in and update these CVMs in place for a lot of the updates, which means miners don't even know that updates are happening. So the only updates that are really happening from a miner's perspective is just stuff that changes in the miner proxy, like this auction system. But the actual CVMs, I think we've only had one actual upgrade that required a full new release since we've done the CVM update, which makes the miners' lives a lot easier and our downtime better because these nodes aren't going offline as often. We can just surgically go into them and update whatever we need to update.
And to build out the market aspect of it, would you allow miners to basically choose these categories, these buckets?
So the buckets would almost certainly be from our side based on what we see from demand from customers.
Okay.
So if customers are demanding 4090s, we want to put on more 4090s. If you do it reverse, if miners have more 4090s, it doesn't make sense to pay them out for more 4090s if no one's going to use them.
Okay. So this is purely based off of demand you guys receive.
Demand we receive, yes.
Okay. Do you think that part ever becomes automated away or abstracted away from you guys and the market gets to determine it directly?
I think in the long-term future, I think that is something we want to move towards. I think the long-term future that we want to do is make this much more of an actual marketplace where we have people. So like the part of the reason we put this out was kind of just for the like baby steps towards this full auction system where people can come in with bids and then we match up the bid, people come in with asks and then match those asks up with bids. So a customer can come in and say, hey, I want a 8x H200 for $1.50. And then now it's up to the miners to provide that at $1.50 and we match up those customers.
Yeah.
Now, how that works, we're still thinking about and trying to figure out. This is the first step that we've taken towards that. But I do think it is a future.
Yeah. So you have one half the order book down.
Yeah.
You have the ask,
the
supply side.
Yep. And where we're at now with inference, it makes sense this way because we basically have unlimited ask. Like we're saying, hey, we just give us as much as you possibly can because the more compute we get, we have the inference to serve to it. So the more we can get, the more we can serve, the better everything is.
There you go. Well, Josh, I'm going to ask you one last question here. What advice do you have for developers when creating an architecture like this for a new idea on Bittensor?
On Bittensor specifically, that's a good question. I think a lot of developers on Bittensor specifically, get caught up in the Bittensor side of things. I think one of the things that you need to be careful about with building a subnet is build the subnet as not as if it wasn't built on Bittensor, but don't think of the Bittensor side as much. Like really the only thing you needed that this relies on Bittensor for in terms of like from a developer's perspective is the validators need to be able to set weights and get the IP addresses of miners. Really all it needs to do. Now, there's stuff like Collateral, there's a whole bunch of other things. But you can build anything you want. So like one of the examples that we give is this is the only subnet on Bittensor that runs purely in Golang. Or interacts with the chain rather, purely in Golang. Why do we do that? It's faster for us to develop. It's much more stable for us. It's just everything faster. There's a million different reasons why we do it. And a lot of subnet developers will come in and assume they have to use Python because that's what is currently available and whatnot. And I've been saying this for a long time. Python is good for like templating something out, but if you want something that scales, like you're going to probably need to look at other options. You can't fix a car with a wrench. You're going to need more tools. And so, yeah, like figure out what your actual needs are and build the system around like what the actual idea is, not necessarily around Bittensor itself. Does that make sense?
Yeah.
Cool.
Well, Josh,
thank you.
Appreciate it, man.
Absolutely. Thank you.
Thank you for the explanation.
Awesome.
Hope that people enjoy it. James, the COO of Targon?
Yeah, that's a good way to say it.
Okay. And then you used to be at OpenTensor. You're now at Targon. You and Rob co-founded Manifold Labs. What is the vision behind what you guys are doing here?
Well, it's a big vision. We're focused primarily on compute. So Targon is a compute subnet, and what we're attempting to do at the moment is create these different markets for different machines. So right now we have a market for H200s. Miners submit bids, and the chain pays out on a per interval basis whatever the miner bids. So right now the market's at about $220 an hour for an H200.
And why is this market-based approach something that you guys needed to build for compute? And why H200s, H100s specifically?
Well, the compute market is really messed up. I mean, it's beyond messed up. The cost of financing is so high for any of these machines. If you look at Lambda, I mean, Lambda is like 15% cost of capital right now to acquire like an H200 cluster. That financing cost is ultimately passed down to the consumer, which makes inference, training, any of these key tasks in AI makes it highly expensive, or more expensive than it should be. And there's a lack of transparency in the market today. It's like trading OTC Discord back in 2021, basically.
Yeah.
Where it's like, okay, I need, let's just say, for example, I need 10 nodes. I need 10 H200 nodes, and I need it for the next month. Well, today, if you want to do that, you need to go find a broker. Your broker likely has relationships with the large data centers, like a public guy like DigitalOcean, for example. And then you have to hope that you can get some allocation. But you don't actually know what the raw cost is. You don't know what the cost of operation is. You don't know what DigitalOcean's actual operating expense is. And you don't know what the broker's taking, so it's a total disaster. There is not, like, for example, the CME. Why has the CME been so successful? Because it's effectively financialized something as simple as corn, right? Trading bushels of corn. Now, you don't have to go directly to some broker from the farmer. There's just one place. It's the most liquid exchange in the world, and you can go get exactly what you need.
So you see Targon and Manifold as developing this CME, this exchange for compute that everyone goes to, suppliers and buyers.
Well, that's correct. I mean, look at what OpenAI is doing with Project Stargate, or what xAI is doing with their cluster, or what Meta is now doing with these super clusters. That is because, one, like fundamentally, why are they doing this? Well, one, they need more and more compute because, as we were joking right before we came on air, everything is computer. So they need as much as they possibly can get. Right now, they're able to do it in this centralized manner because their cost of capital is next to nothing, right? You just sell equity, and your equity is very, very richly valued. Maybe some people think it's fairly valued, but whatever. The thing's worth trillions of dollars, so you can just go sell into the public markets. It's very easy to do. The problem is, maybe the bigger problem actually, is the power. I was reading the other day, xAI has a new site in Memphis. Well, right now it's not fully operational because if you were to power these hundreds of thousands of H200s, you're really impacting the citizens of that city, the city of Memphis. You're making it much more expensive for them to live there. So there's repercussions in places that maybe you don't really think to look at, which means that in order to make this truly efficient and scalable, what you don't need is these clusters that are the size of Manhattan. What you probably want, if you could pull it off, is, a couple $1 million of hardware here, 30 million there, 100 million there, and it's all connected. And there's a public, transparent, liquid exchange where you could envision an OpenAI saying, okay, we've forecasted this demand for ChatGPT over the next year. Therefore, we believe we need this many chips. Okay, let's come on to Targon. I want to buy a block. I need 20,000 H200s, and I want them for the next year. This is helpful to OpenAI, clearly, right? Because they get the supply they need at a price that they like. This is helpful to the operator. If you're a compute provider, the most important thing, it's not even a question of what's the most important thing. It's utilization. If you can go and get 100% utilization, you win, right? Because you can pay back your debt guy, and you can keep reinvesting into the newer hardware. That's what Targon offers right now. You can almost think of it, and I know our friend Mark Jeffrey, he talks about it all the time. Uber, Airbnb, he's right? What did Uber do? They said, okay, we want to connect supply and demand. We want to connect drivers with riders. Well, if I want to get an Uber, if you and I want to go get an Uber and there's no supply, we're hosed. I'll never touch Uber again, right? So the most important thing initially when you're seeding the market is the supply side. That's where the incentive is very powerful, because we don't have to have all of the demand in the world right now. It's growing, but it lags supply naturally. It just lags by a few weeks. Because imagine if you go to a client and you're like, hey, I've got all of this compute for you, but really you have to go get the compute. You don't actually have it yet. You're just trying to sell the guy. And then he's like, okay, now there's a 2-3 month lag. This exact phenomenon is occurring right now, and it occurred really infamously with the H100 rollout about a year and a half ago. We bought a very small cluster at Manifold. The salesperson who sold us the cluster was like, oh, we'll have it in a month. Month comes, we don't have it. A month later, we still don't have it. There's all these supply chain issues. So you need to have the supply. The incentive, it's very powerful. We can offer 100% utilization to compute providers. These compute providers are operating in a very competitive market right now, where they're asking, they got to set their ask price. So it's kind of like a race, and we're driving the cost down. Something we can talk about later, not to ramble here, but cost is only one part of it. You don't want to become a public dumping ground. That would be the end of Targon, I think, if that happened to us. If it's just this place where, mid-quality providers go and say, oh, well, I can't sell this out because it's inferior. Well, I can go suck off the inflation from this network. I'm going to immediately sell the token. Then you have down-only sell pressure. You don't have any demand because you can't generate demand because you have garbage compute. So quality checks are super important, and something that, we could certainly unpack.
And to create a market of compute, you need that liquidity there for the adoption. How do you bootstrap that liquidity? Is it all based off emissions? Because if emissions decline, then wouldn't liquidity decline with it?
Correct. So it's a unique moment in time, and I don't think we have a lot of time. I think we have 6 months, maybe 12, where if you don't get organic demand, it's done. It's just going to death spiral. Some subnets will succeed and generate organic demand, others won't. But that's the beautiful thing about Bittensor, is people always say, right? It's almost like this venture ecosystem. And so the desire for organic revenue it's loud and clear, and everyone can understand it. It takes about half a brain to understand why you need it, right? But you also have to understand that building a sales cycle, getting the compute, we call it compute efficiency. It's the most important metric right now for us, because we have a fixed amount of computers. We got about 1,300 H200s on the network today. Well, imagine if you take one client and you're serving them with 300 of the 1,300. Well, then you can't really have a lot of clients. So we're investing a lot right now in what we're calling the Targon inference engine, where we are basically spending all day long, a good chunk of the team, just figuring out how do we get the exact same quality of output, speed, all these important things, with less compute, or with lighter weight hardware, if you will. L40S, right? You don't have to run everything on an H200 or B200. It's good for training. It's good for running the larger models. And then as well, how do we think about, okay, how can we build a very high margin business, which is fine-tuning? OpenAI is doing this right now, but the minimum spend is $10 million. So and that makes sense for them, right? Because they can only fine-tune so many guys. But what if we could offer this as a service as well, where we say, hey, within Targon, within these clusters, if you would like to upload your data, we will fine-tune a model for you. We'll take this DeepSeek model from 671 billion hyperparameters down to something that's far lower. Look at Dippy. Dippy's a great example. They've got a 12B that they run. It's lightweight. We don't need as many nodes. We can give them a great experience. It's also, most importantly, better for their users, because that model is specific to Dippy's use case and what their users expect.
And in terms of organic demand, you guys are doing above 15 billion tokens per day, I believe, currently.
That's right.
Rob said in the last podcast I did with them, once you guys get to that 12 to 15 billion mark, you guys will be fully self-sustaining. You don't even need emissions to sustain Manifold itself. Is this true? Are those numbers what you guys expected? How do you project growth in organic demand?
Yeah. Well, you got to define self-sustaining. I think we're certainly as sustainable as we've ever been at the Manifold level and at the subnet level. We're returning over the last 8 days. This was 2 days ago when I looked, but from an 8-day period, what's today, the 17th? So from 7/7 to 7/15, we returned $52,000.
Wow.
Over 8 days. That's about 1/7 of the incentive. So we're 1/7 of the way there. Now we can get into all these things, right? Where, okay, well, what multiple does the market place on that? If it places a decent multiple, then you're sustained at least temporarily via increased speculation, because people say, oh, well, there's nowhere else where I can get this kind of return because we're putting it all back into the subnet. We have our buyback wallet, and when a client pays us money, boom, it just goes straight there. And it just immediately buys back subnet 4 alpha. I think that's the most sustainable way to do it right now. And the way to think about growth, there's 2 ways to think of it. You have the revenue, and then you have your cost structure. So compute efficiency goes into the cost structure part. And that's where we're investing a lot of time right now, because again, if you're taking up a huge percentage of the pool, or the supply, with only a couple clients, then you can't get any more clients. So there's a couple things. It's compute efficiency. It's getting more compute, right? So how do we go from 1,300 H200s to 2,600 to 42 or 5,200 in a sustainable manner? You don't want to just gunshot. Like if someone gave us 10,000 H200s today, that's actually not a good idea, because then you're wiping out the high quality providers. The high quality providers just demand a higher return. So right now we have the H200 hourly interruptible market, which means a miner can put a node on and then at any moment just take it off. This is interesting. It's good for the supplier because it gives them maximum flexibility. Whenever they have downtime with their traditional clients who they sign contracts with, they can come onto a network like Targon and they can monetize. It's kind of like Bitcoin mining, where it's like, oh, let's go put a miner next to a big grid in a city, and let's just say, hey, if you ever have unused electricity, don't put it to waste. Let us take that at a discounted rate. We'll turn it into value, right, via Bitcoin. And the marketplace has a lot of value on Bitcoin, especially these days. And so it's a similar concept, but that's bad for our clients potentially, because you have to have some level of redundancy. And so what we want to introduce is collateral, where the bigger players can say, hey, I'm confident in my hardware. I'm happy to commit to 99.9% uptime. I'm happy to commit to 24-hour notice before I pull a machine. I'm happy to commit to X networking speeds. And if I ever fail, well, you slash my collateral. So yeah, it cost me $2-3 million to play in the big boy league, but I get a higher rate because now there's only 3 or 4 guys, maybe initially, who can post $3 million of collateral, and they themselves will be, I don't know, probably closer to $3 an hour. There's CoreWeave. Look at CoreWeave. They're at $5-6 an hour. So collateral will be a big unlock. So to answer your question without just totally rambling, is we need to be hypercompute efficient. So that's the Targon Inference Engine team. At the same time, we need to ensure that we're, doing well by the miners and ensuring that it's like a fair game for them to play. They can grow their fleet sustainably. At the end of the day, we don't have a business if we don't have compute. So we need to make sure that they're getting paid out, right? The system is fair. And ultimately, most importantly, it's good for our users. And by driving down cost in the interruptible, you can give a cheaper price to the public cloud on Targon. And then once you introduce collateral, now you can really get into the growth phase, which is the enterprise clients. And Dippy, for example, they're going to be our first real signed client on like a 12-month term. And wow, there's a fire truck coming. That's one of the pros, or maybe the cons of doing it outside. The pro is that you know what's going on. The con is that you got to listen to this thing. It's really loud. I don't know if
I bet it won't even pick it up. That's
really?
the crazy part. Yeah.
Well, we just talked about it, so people
Yeah.
can look it
People
up.
could know. Maybe they see a reflection somewhere.
Yeah, people might know. So assigning these clients, that's the high quality revenue, right? Because you can say, okay, you pay 25% of it up front. You're committed to use Targon for a month. At the end of the day, though, selling inference, it's a game of survival, like you mentioned, because if you're relying only on the emissions, it's only a matter of time before you don't have anything anymore. And there's a lot of these guys who want to sell inference because it's not that complicated. So for us, the moat that we really believe we can have is through the exchange, the liquidity. How do you identify what a quality node is? I guess the question to ask, and maybe ask the people who are listening, is do you believe that all compute hours are equal? If you do, then you should say a node in India is the same as a premium node in the United States of America, and then just go race to the bottom zero. If you don't believe that all compute hours are equal, then you probably want to build something like this, where you can better define and create these micro markets. And then anyone, it's just completely agnostic. It could be OpenAI, it could be the University of Texas at Austin. They want a block, they can come and see what it costs.
I think you're a financial markets guy. Do you anticipate introducing something like a credit rating of bonds where there's AAA compute versus different levels that way?
Perhaps. I think the market, we don't necessarily need to be, take that much, how would I say it, control over, where the market's going to go. I think the market will actually figure that out for us. And, if you're with a provider and it's horrible, well, then you'll probably tell your friend, hey, that provider that you see on the order book, don't even bother with them. Their price will go lower. So I think a lot of that stuff can happen naturally. But in the spirit of talking about financial markets, yeah, you're correct. There's a lot you can do once you financialize this asset, which I think is where the world is going. Because when you really think about it, if I am an operator and I've taken out however much debt to acquire this hardware, well, I need a certain return. In the spirit of a contract, I would love it if you bought a block from me at the spot price 12 months from now. Right now, if I'm trying to figure out what is the spot price of an H200 in 12 months, there is not a market for that. It just doesn't exist, right? It's like two guys, like say I'm at OpenAI, say you're at Targon, which is role reversal here, kind of, and we're trying to broker a deal. It's just us talking, trying to figure it out. That's not efficient at all. So by introducing the market, you introduce this forward contract, which is good for the supplier, but it's also good for the consumer, because the consumer, you want to operate your business. You don't want to sit around all day saying, well, fuck, I don't know what this is going to cost 12 months from now. If I could just forecast it, I'm willing to pay 5-10 cents in a premium for the peace of mind. It's like the whole idea of an option, right? There's a lot of degen activity these days of people selling, buying naked options. It's not what an option is meant to be. An option is to hedge price risk on either side.
What are the next steps in building out this essentially futures market for compute that you're describing?
Well, there's a lot you need to do. I mean, you got to get it regulated. That's much further down the line, right? You need like DCM licenses so that you can sell these future contracts. And there's a lot you need to do there. And we're very early innings on just thinking through that. But in the very near term on the subnet, we introduced the new update on Monday with Targon, the order book, which has gone incredibly well. It's actually been remarkable to see. The first 24 hours, it was kind of like everyone's figuring it out. And now that we've had the same participants for basically the whole week, the market has arrived at consensus at 220. Previously, we were paying closer to 250. So all we did was introduce one thing, which we asked the participants, what do you need to get paid? Not, okay, take your pro rata share, no transparency, race to the bottom. It's, if you're an operator, your edge is the ability to drive down your cost without driving down the quality of your compute. So Right now, it's just let's create more markets. Forget about the DCM for now. That's so far away, it's not even funny. But that's where you need to go if you want to be serious.
Yeah.
You got the H200 hourly interruptible market. There's nothing stopping us from having an H100 hourly interruptible market as soon as tomorrow. I think that'll come here within the next few weeks. We can have an L40S market. We can have the Collateral market, where you can, again, take similar machines and say, okay, if you want to play in the big boy league, commit to these things. Well, the max that you can bid, because right now on the interruptible, you can't bid more than $3 an hour. If you're in the Collateral market, that's going to be higher because it's higher quality compute. So to your question about the rating, the Collateral kind of gets you there, gets you close enough without us having to be Moody's. I mean, who the hell wants to be Moody's? Moody's is a decent business, but it's not super interesting to me. So creating the exchange, it's really, we got to get the supply, which we're doing. We got to grow it sustainably with demand, with high quality clients, and then continue to go, and the flywheel will go from there.
And currently, your system is the supply side sets their bid rate, essentially, saying, I want to get this much. How does that mechanism work from like a simplified standpoint?
Yeah. It's a good question. So it's actually interesting right now. Here's a little alpha if you're a miner. All the miners are at 220. Every interval, I think we have about 1,300 GPUs, and we can only afford, Subnet right now can only afford to pay out $2.03 an hour if you're paying pro rata. And so if everyone's at 220, all that's really happening is you're paying them out pro rata. If a miner comes in and bids 219, well, they become the first ring. We think about everything in rings. They would capture all of that 219. So imagine if a guy with a couple hundred of these GPUs says, I'm going to go from 220 to 219. Well, he just took 219, and he will drive the rest of the market. I modeled one scenario out this morning. I said, what would happen if the largest miner goes to 219? Well, he gets all 219 instead of 203. Great deal. The rest of the market that's currently at 203 goes down to $1.92. So what we're doing is you are incentivizing people to bid as low as possible. What you could argue is occurring right now is the miners, perhaps since there's only 5 or 6 of them, is they've kind of created this cabal and said, let's all just bid 220, let's get our 203. I don't actually think that's the case, but you got to think through everything. I anticipate a miner here, probably within the next few days, maybe even while we're on the podcast, if they're smart, they'll bid 219 and take as much as they can. So the way it works is there's a fixed amount of money available. There's supply that can come onto the market. As the supplier, you set your ask. You say, I need this much. If you're the lowest, you get paid out. So it's like an order book, right? The lowest are eaten first. And then if you can pay everyone, then you pay everyone what they ask. But as you know, when you introduce competition, people drive down lower. And then if you can get scale, this is a commodities business. You have to have scale. If you have scale, then you can eat everything at the lowest price. And then there's no room for the tiny operator. And it's nothing against tiny operators. There's room for tiny operators, right? You needed to bootstrap the market. There will always be a place for the smaller guy. But if you're a small oil guy, you're just never going to compete against Occidental. It's just not going to happen. You can carve out a nice little living, but you're not going to build a dynasty. And so these guys, I think some of the bigger guys, publicly traded companies who aren't totally playing here yet, but I think they will be soon, you know, they're going to be able to operate at scale and still maintain quality.
And you have coined the term, or at least you're the first person I've heard use the term, the institutional miner. To onboard institutional miners, or what you deem an institutional miner, first, what is that? Second, how close of a relationship do you have to build with these data centers to be able to bring their compute online?
You know, originally I thought it was going to be very difficult, because when you think about it, it's Tau. Okay, what the hell is Tau? Now you got an alpha token. What the hell is this? But Since the North Star metric for the operator is utilization, they'll do just about anything, including bending over backwards to bring their hardware onto the subnet. Because if otherwise it sits there collecting dust. And even if you're offline, if you're one of these bigger guys for just a few hours, it's thousands of dollars in opportunity costs. So they're willing to figure out, oh, wow, okay, this thing's on Coinbase, it's good enough for me. So that's actually not the super hard sell. It's more just getting introduced to them, getting time with them. These guys are busy. There's a lot of people who want compute now. And if you run a good business, which if you're a publicly traded company and your stock's doing well and you've been in business for a while, you probably know what you're doing. You don't actually have a ton of excess utilization, but that time is coming, especially on hardware that's maybe a year behind. Look at the H100. There's a larger one. They've got hundreds of millions of dollars. I mean, hundreds of millions in H100s, and it's kind of just sitting there. You know, they can sell a contract here and there, but the OpenAIs, which is the large part of this industry, Microsoft, I mean, it's really just 10 guys consuming the lion's share. They always want the newest stuff. So once your cycle's up, we offer, you know, at Targon, we say, well, we can still make use of this compute. It's actually really good for a lot of these inference jobs. And so an institutional miner is nothing other than, and an individual can be an institution. Anyone can be an institution these days. It's more about the mindset, right? Where you own the hardware. You have the ability to scale with us. If you don't have that, then you always remain small. Right? It's like you want to own things in life. And so initially, a lot of the miners were just renting from brokers. And if our whole thesis is, well, I just told you that brokers are making the price of compute inflated, then unless you can get a really good deal from a broker, I mean, you got to be best friends with the broker, or you got to be like the guy at the Coldplay concert, you know? You got to be the CEO and the HR woman. Did you see this yesterday? The Coldplay
on
thing?
the Jumbotron?
Crazy, huh? You got to be like that with your broker if you want to compete moving forward. So it's nothing more than you have the ability to scale and scale quickly.
Okay. And the idea of creating a market, the main thesis is to remove the middleman between the supply side and the actual user. Will Targon sit as a centralized entity between the supplier and the end consumer, similar to Uber with that pricing model? Or is it purely just build an infrastructure to connect the two?
That's a beautiful thing about Bittensor is we don't need to do the Uber way, which is much harder. I've actually seen people who are trying to do the same thing. The beautiful thing about this idea is it's so simple that even we can talk about it, right? It's not like this crazy abstract thing. It's simple. So how are you going to win? You're going to execute better than everyone else. Okay, well, how do you do that? Step one is the supply. Cool. We have the token, we have the incentive, we can bootstrap supply. We don't have to go raise millions, hundreds of millions, billions of venture capital money, light it on fire and hope. Hope and pray that one day we can create the market. The market's kind of here for us now. Anyone who holds Subnet 4 Alpha token is the Uber, right? You own your share of it. If you hold the token, you spin up a validator, you have direct access to the hardware. It's really, really cool. And we have this shared. It's funny sometimes because whenever you release an update, some people love it. A lot of people really hate it, especially the miners, because they're like, oh, well, does this mean I don't make as much money? And I understand. That's their business. If someone is threatening your business, you might not like it. The thing is, we come in peace. We're not trying to threaten anyone. Like, if you're here today, you want this to grow and become efficient. There's two options, really. Option one, we stay small. We play the broker game, we try to eke out a few things, or we try to go. Like, we're up at home plate, bases are juiced, and can we hit it out of the park or not? That's what creating the most liquid exchange in the world is. And so to answer your question, people who are trying to do this, sitting in the middle centralized, I don't think it's going to work very well because think about it, if you're a compute owner, would you rather come to Targon where you get paid here no matter what? I actually call it decentralized demand. You don't necessarily know who the client is, but you're paid out via the token. It's actually kind of awesome. Whereas if you're like just trying to spin this up old school or Web 2 thinking, well, then you have to go get the client. They need to send you money. You need to take that money, pay out the provider. There's all these steps here. There's a lot of client risk. Here you have the speculative element that bootstraps Bitcoin. Some people say, oh, I don't like speculation initially. Well, you kind of need it initially. And everything great starts with speculation, even if it's venture capital, seed, equity, and Uber, right? That's speculation by definition. So ours just looks and feels a little bit different. Maybe it's hard for some people to understand initially, but as long as it makes sense to you and I, and the initial group of people who are going to get this thing off the ground, and it's growing up quickly. Like our metrics are up and to the right. It's kind of cool. Like every morning I open up Stripe, there's money in the account. This used to not happen. I would open up Stripe, $0, $0. Now it's like hundreds of dollars overnight, thousands. It's awesome, and it's going right back into the alpha token.
And you're no stranger to building up that initial liquidity. When you were at OTF, you're the man responsible for getting Bittensor on MEXC, its first centralized exchange.
Oh, yeah.
So you have experience in these markets. How does that experience translate to how you think about building Targon and Manifold in these markets for compute?
Well, that was actually pre-OTF. That was how I got introduced to OTF, was in 2022. Saw the token. The token was about as illiquid as you could possibly imagine. It was on this thing called Tensor Exchange. Do you remember?
I remember.
Unbelievable. So the thing's horrible, the liquidity is horrible, but this thing had so much promise. We could see it. And so we got onto MEXC. It was totally complicated. JJ bought his first Tau through us, I remember it. It was like not a huge order, but it was huge at the time, actually. I take a lot of that experience. It was one of the most fun times in my career because no one wanted to do that Tau deal because typically you have to structure it with the foundation. OpenTensor wanted no part of it, so we had to talk to bigger players like individuals and larger investors and convince them to do it. They didn't really want to do it. They didn't see the value. The firm I was working for didn't see the value. Like, who the hell are these people? And so that required so much persistence, months of it, just to get it onto MEXC. I remember just walking around New York, like being so excited when we got it closed. It was awesome. It was really cool because there was uncertainty as to whether you would ever get onto MEXC. Nothing's inevitable in the world. I believe this strongly. It's not like, I'll create this great idea and then no. You need to have, that's a prerequisite. Like you need that, but it's not sufficient. Like you also just need to kind of brute force your way and meet reality where reality is. So I take a lot of these lessons. I know how markets work at a deep level. I know what this will look like if it is to succeed or when it succeeds and what it takes to get there. So combining like the vision with the pragmatic day-to-day and making sure that if we just one step at a time, right? Like the step one is, okay, let's introduce the ask, the order book. That's a step in the right direction. No one, the Wall Street Journal is not going to pick up on it, right? Who the hell cares in the real world? But we care because it's getting us where we need to go for people to take us seriously. So we can actually go to OpenAI or Anthropic or Microsoft and say, hey, do you want to buy a block of this compute? HIPAA certified, fully compliant in every way, okay? Best price in the world, totally liquid, you'll be online in 5 minutes. That's a pretty good sell. I always show you can be the worst salesman in the world and you'll sell it, right? And you can, so it doesn't really matter who it is pitching because they'll sell it. It's easy. So the market stuff is part of my background and something that I always keep in mind.
And then one last question before we wrap this up, or one last question to wrap this up.
Okay.
Being from that market background, having the business perspective, what advice would you have for people in Bittensor with that business sense in mind to be able to say, this is the end goal, this is our aim, and actually break that down into tangible steps, like creating that ask order book, the supply side? How do you break down the bigger goal into tangible small steps?
Well, it's important to always think, why are we doing what we're doing? Why? I mean, there's all these buzzwords. A lot of people get super excited about what could happen. But fundamentally, on Subnet 4, we need compute. That's why we started Subnet 4. Oh, I think compute is going to be a very large commodity tomorrow. It's pretty big today. I think it'll be larger tomorrow. Probably not a crazy thing to say. People are going to use more compute tomorrow than today. So what on your subnet have you produced? Like, what commodity? Ultimately, I think everything on Bittensor is a commodity. That was the premise initially, and I think it holds true today. A digital commodities marketplace. How do you produce this in the most efficient manner possible while maintaining quality, price, whatever it is that you're optimizing for? It might be a combination, like in our case. Then, and only then, that's the most important part, right? Imagine if you have some garbage. If you're a corn guy, it's commodity, but your corn is small, tastes horrible. You got to do the commodity first. Okay, check. Now, what does selling that commodity look like? And how do people who do it in the quote normal sort of Web 2 way, how do they go about it? And what lessons can you learn from them? And then just go and sell it. Package it up for people so that it makes sense. Don't confuse them with jargon, right? We have to understand that we're much further ahead. You know, we're like 12 layers into the matrix, you could argue. And so we need to come and meet people where they are if you want to have a snowball's chance in hell of selling the guy or the girl. But it's quite simple, right? What commodity are you producing? And then how will you package and add additional value on top? If there's no way to add additional value on top, that's also okay, because you can succeed in a commodities market at scale. This has been a theme of this conversation, right? Scale is very important. And so if you have the most scalable, most liquid market for your commodity, well, that's highly successful too. Your alpha token will be very, very valuable. But you can have both. You can have a very successful commodities business, and then how do I get margin on top? And then how do I, with that margin on top, reinvest aggressively, as aggressively as you can possibly stomach, into the flywheel so that you can grow and scale faster than peers.
Well, James, it's been a pleasure, man.
Of course, anytime. I'm always happy to do it.
Absolutely. And that's a wrap.